So, the most important thing, I think some of the speakers have already said, a leader should be an excellent researcher, innovator in any organization. I'll tell you because if you don't have a leader who is leading a company or an institution, who is an authority in the area, who is somebody people will look up to him, then that organization will not go. See, the reason many universities in the United States have prospered, if you look at the dean and the director and the provost, they are the best in the area. They are members of the National Academy and so on. And that, I think, should be the bookmark for us also in India, because there are many, many talented people. But it does not happen, because I always follow the advice of Professor S S Iyengar. I meet him. There are people come here, they're just bureaucrat, they don't write. Because that's not going to work. I think the trend has changed. But you see, what I'm going to do today, rather than just sort of repeating all the things have been said, I'm going to show you an example, a real example, what has revolutionized sensor networks. That's my area. And in fact, this talk, I'm sort of reproducing it here because rather than just talking about collaboration, innovation is needed, but I have shown how it works. So that as I think, leading by example is something very critical. Okay, so I call it as an acceleration sensor-driven information technology. Now, research is very important, I'll tell you. I'm in fact even disappointed with the Indian Institute of Science. I was an old student of Indian Institute of Science, and I got the Distinguished Alumnus Award. But the rate, they could do, the students are the most brilliant students, but the output, as I even hear from CNRO, is not at all good. There are students taking 6 years, 7 years to do PhD. The time is lost, the technology is changed. So I am giving even most of the best schools in the country, they can really outshine many of the best universities abroad. But an example which I show you should classically tell you what needs to be done. So I will show you the success of the collaboration, what happens here. This is actually a keynote talk I gave, and there is a Taichung in Taiwan. Just during my visit to India, I visited many good universities. There is a university called Tsinghua University, the most famous school in China. That is equivalent to MIT or Stanford of the United States. The National Taiwan University, like our Indian Institute of Science and IITs and so on. So this talk I gave, and I'm going to sort of repeat that. What is collaboration? Because this is very important, because we talk about collaboration, but you see, collaboration is good. It needs to have a good story at the end. It needs to have a good impact all over the world. I'm not just talking about India or China or anything, this is how the universities will grow. So I'll tell you, so we designed a mobile-based platform for context monitoring. So there are sensor networks which are pretty much available nowadays. Now, what is that we are really interested in is in the context-aware applications, like for example, I would like to have a sensor, we talk about nanosensor, that what is the end product? I want to see that. But here, we show that this kind of context-aware application is going to be the future. They can constantly be with the doctor's communication. And if for some chance, if they forget, automatically they will get a message that, oh, your drugs, your blood pressure medicine was supposed to be taken this morning at 10 o'clock and you are not doing it. So it is a very beautiful...
I just took my medicine now.
Okay, good. Well, of course you are an exception here, but in general, so these are the kinds of things that always happen. So, and then when we develop many of these smart chairs based on sensing, these are energy limited. That means the resources are constrained. So what we want to do is how you provide a developers like Samsung or Apple or any other places a platform, a structural platform, so that an effective runtime can be used and then the whole application can be sort of used. So that's the context-aware application, but I'm going to take two examples. Now, this work was done jointly with Korean Advanced Institute of Science and Technology. How did this happen? So, Korean Advanced Institute of Science and Technology, that is the best school in the Korea. I don't know how many of you are aware of it. They are the cream. The best people come out of that school, like Stanford, MIT, Berkeley. Okay, just to give you an example. So I happened to give a talk. After my talk, there were a lot of companies were there, including Samsung and so on, and there were many professors. And they said some of the ideas that you are mentioning is very good. I would like to have a discussion on that. So that is how the collaboration started. So once I gave the basic idea and the concept, they sort of said the companies, context-aware application is more critical and is very timely also, because that's what it is the future is going to dictate. So this is what we call as the continuous context monitoring. Here is an example. So suppose somebody is running, jogging. So I would like to sort of monitor the continuous heartbeat. So that means I need to be able to have this body sensors embedded on this person. Because jogging is also, it can be fatal too. Because sometimes if you do an over jogging, people will sort of fail. They'll have a cardiac arrest. So that's one thing. Or they can also sort of systematically see how well they are jogging. So that's one good example. So what we are really talking about is a system which has got 4 different types. So we know the application. The application requires a complex number of sensors embedded on the body, built-in systems, and they were continuously monitoring, like how fast is jogging, she or he, and how is good, and what kind of metabolism, this. So this is a very practical example. So I have developed basically a theory, and the Samsung and other companies are very much interested in translating that into a real application. So we talked about it. So what kind of application logic that we need to use? Now we need a sensing. It has to extract some features. What kind of features? I need to know what my heartbeat, what is my, the signaling of the electrocardiogram of the heart, and then how can it recognize? And it is all to be done on real time. So what kind of distributed computing platform that we use? So there is a whole lot of issues that have been designed. So here are some examples. What are the vital signs of information? Then, if it is a very hot day, then it is also not advisable to sort of jog. So what kind of environmental features that have to be done? Because eventually I need to have that mobile application platform on my iPhone, because I should be able to use it along with when I am jogging. And the location and the activity of what the signal. If I am sort of running around this area, then I should be able to sort of get this. So you get a variety of data that needs to be sort of looked at it, and this is what we call as a context. So if you look at it, that means we'll be using lots of sensors. It may be tens or hundreds of sensors, and these sensors are heterogeneous sensors. They are not all of them reading the temperature or pressure. So the question that comes here is, how do we fuse this data? That's one interesting research problem. And now, when you have large amount of data that is being collected, the next interesting thing is, how do I update the data? Because 15 minutes back I was jogging, now I am jogging at a different times. So that's, how do I do that? Now, you remember, the resource limitations are there with many of the sensing devices. One, they are not accurate. Sometimes they are battery operated, and so the processors they have. But there is a lot of sophistication sensors. There are what are called as smart sensors or smart dust. I can throw it in the air and I can collect data. So coming up with a sensor that is needed is not an issue at all. it may be a little bit cost trade-off. Some of them may be a little more expensive, but depending on the kind of the kind of a thing that you need. Now, there are other important components that we need to be looking at. It is we need to locate where exactly the person is. So this is what we call as a health monitoring system. Now, there are other additional information. The person who is jogging, does he have a doctor in case if there is a car? Now, does he have insurance? In the United States, you know that if you don't have insurance, the health treating of individuals are going to be fairly very expensive, or they may not do it. So then what can you learn from these kind of systems? And suppose there is somebody who has a blood pressure and has a little bit of a diet problem, do we have a count of the diet that he is taking? Okay, so and then the constant reminder in terms of medication, and then there are behavioral cards. So do you get a complete picture of the entire data that we are sort of monitoring based on the context? I mean, the context is the one which is very, very important on this. Okay, so what are the challenges? So this is where the collaboration is very important. So we need industries where they can take our ideas, algorithms, and put them on a chip. And then there are people who can test it. Then we have some students who can sort of do a lot of simulation studies on that. And there are different universities are also involved in it, because the university can provide a rich, what we call as conceptual experience and the background in many of these applications. So, but these are very competitive and challenging, problems. So there are a number of applications like scale resources, how do you optimize the energy, what kind of protocol, and what kind of computing platform that you have. For example, this case, like the mica modes have very limited amount of CPU, and so there's a whole lot of issues on that. So, and then the kind of data that we are generating, sometimes it can be dynamic, it is constantly changing. And so there must be a synthesis of these data, and so that they'll be able to sort of come up with a decision making. Suppose, for example, take up a watch sensor, so you need to be dividing and designing what are called as smart sensors on this. So the principle behind this is dynamically there are lots of. So let's go back one more step. The applications themselves will not solve the problem, because context monitoring is a very important problem, but it is also, it needs a lot amount of programming to come up with that. See, the iPhone that you use, I mean, that has a lot of hidden programming that you may not know. I mean, you may be able to communicate, but interestingly, what kind of communication protocol, what priorities. So there's a lot amount of programming, debugging on many of these sensor devices also. And sometimes these can be, so programming on these kind of dynamic applications, the challenging is programming. I mean, these are doable, I'm not telling you, but what I'm trying to give you is also sort of involves a amount of fairly complexity embedded in that. So the awareness of the required amount of resources is also very critical. Then we should also be able to sort of see, we cannot just develop these kind of mobile applications for one program. Can we sort of generalize it into other applications? That's also very, very important. So this is a platform that we designed, and we call it as orchestrator, okay? Now, that means there is a certain amount of learning is embedded. Now, when you are sort of developing these kind of context-aware application, certain amount of, privacy, the security is also involved, and then what kind of communication protocol. So you see that a variety of programming as well as software embedded tools, in addition to the hardware design, is also a part of these mobile application. Now, at the bottom that you see, there are different types of sensors we are using, accelerometers, GPS, and so on. So it is really an integration of all of these devices into a mobile computing platform. Okay, so now I'm not going to go into the details of the technology here. So we were able to sort of look at the user and the developer, and then we said what kind of declarative programming and high level of representation that is needed. So take simply context. Activity is running, and temperature is very hot and humidity is wet, so then we need to give an alarm either false or true. And suppose if you are collecting the data for 1 month, so these are all the kind of features that we need to be able to recognize from these mobile applications. Now, the next thing, of course, is how do you make it energy efficient? These are challenges, but we are providing solutions, and that means you need to sort of avoid any of the unnecessary data transmission, okay, from wireless sensors, because that would cause. So if you have to put them to sleep, you should do that. So use sensors only when it is needed. So here an example is identification and deactivating unnecessary sensors. And a query something like this is the weather is hot and humid. If it is already cool, then there is no point in having this kind of query. Then we will certainly avoid this kind of. So this is some kind of example. So we define what are called as a concept embedded as a complete sensor set. So these are all some of the applications, and these are all the evaluations. Now, there are lots of interesting ideas and technology that we have developed on this. Because of the time, I'm not able to show, but a paper, this has been published and is an award-winning paper in communication of ACM. I think you guys should be able to do that. So there are other interesting aspects of it. There is one thing which I want to sort of, we did a lot of experimental setup, a prototype before implementation, what are the alternatives and so on and so forth, and sensor availability, the workload, and so on and so forth. So what is very important here is a collaboration between a major industry like Samsung and a great university like KAIST and our university and lots of other research laboratories in and around the world. Now, a byproduct of this prototype mobile application is also what we call as a game. Nowadays students are interested in playing games. Okay, so we developed what we call as a mobile social execution game. Now here is a game played by two different people operated on the same data from two different sources, different places. So this is very critical because here is a visualization that you can see, because if I am working on this to develop all of the real-time applications. So here is a simple example, and again I think I'm going to leave this, I visited Qualcomm. How many of you have heard of a company called Qualcomm? Very famous company. This story I'm going to tell you and then close it. I was invited by Qualcomm at San Diego just last month. Now, my idea is collaboration with Qualcomm. So I did a lot of good homework, and I happened to meet a very good friend by name Dr. Arvind Jacobs, who was the co-founder of this company sometime in early 80s, and that company is $1 billion company because we need a collaboration to enhance our students' ability. And he won the IEEE National Medal of Science, is very important. So I would like to see Arvind Jacobs' history is very good because he graduated from MIT and then he was a faculty. Then he said, look, I want to do something which is very impact. So one day he resigned from the university and took a car, drove all his family to San Diego all the way from Boston. It took 3 or 4 days, and then he started this company. So he came up with a device, a communication device in those days, which was being used by many of the devotees, and it became famous. So I would like to see, honestly speaking, in this audience or any audience in India, somebody like Arvind Jacobs, very entrepreneurship, very innovative, and a person of the highest caliber and a very humble person. Well, thank you very much for this introduction. Thank you.